Alright, now we proceed to the next example, how to calculate or compute the coefficient of correlation. And for this example, we try to compute the value of correlation coefficient for the data obtained in the study of the number of absence and the final grade of the 7 students in statistics class. Okay, this is just like the previous example that we get the scatter plot, and the same question. Now we try to compute the correlation coefficient. Alright, so the formula, okay, the formula that we will use for the correlation coefficient is R. Okay, R uh, is equal to n, the sum of xy minus the sum of x multiplied by the sum of y, and all these divide by the square root of n multiplied by the sum of x square minus the sum of x all this square, and multiply by square root of n, the sum of y square minus the sum of y and all these square. So this is the formula to find the correlation coefficient or R for the sample. And what we need now is the sum of x, the sum of y, the sum of xy, the sum of x square, and the sum of y square. So from this we can get the sum of x. Okay, you just have to total up all the values for this column, and the sum of x is 57. Okay, 57. 6 plus 2 plus 15 plus 9 plus 12 plus 5 plus 8. And from this column we can get the sum of y. So 82 plus 86 plus 43 plus 74 plus 58 plus 90 and plus 78, and the answer is 511. So now we need the sum of xy. So for the new column we have to find xy. So x multiplied by y, so 6 multiplied by 82 is 492, and 2 multiplied by 86 is 172. 15 multiplied by 43 is 645. 9 multiplied by 74 is 666. 12 multiplied by 58, 696. 5 multiplied by 90 is 450, and 8 multiplied by 78 is 624. And total up this column, we will get the sum of xy. So the sum of xy is 3745. Okay, for the next column we have to find y, and the sum of y, we have to find the sum of y square. So for this column is for y square, so you just have to square the value of y. So 82 square is 6724. 86 square is 7396. Then 43 square is 1849, and 74 square is 5476. 58 square is 3364. 90 square is 8100, and 78 square is 6084. And total up this column is for the sum of y square. The sum of y square is 38993, and the last column is for x square. Okay, so you just have to square the value of the value of x. So 6 square is 36. Then 2 square is 4, 15 square is 225, 9 square is 81, then 12 square is 144, 5 square is 25, and x square is 64. And total up this column, so we will get the sum of x square. The sum of x square for this question is 579. Right, so now we have all the values, and we just have to substitute in the formula to get the correlation coefficient. So in the formula, n is the number of sample. So the number of sample is 1, 2, 3, 4, 5, 6, and 7. So 7 multiplied by the sum of xy. The sum of xy is 3745 minus the sum of x. The sum of x is 57. Multiply by the sum of y is 511. Divide by square root of n is 7. The sum of x square. The sum of x square is 579 minus the sum of x. The sum of x is 57 square. Multiply by square root of n is 7. The sum of y square is 38,993 minus the sum of y is 511 square. So now you just have to use your calculator to find the answer. And the answer for this question, the value of r is negative 0.944. Okay, 0.944. So please take note, the rounding rule for the correlation coefficient, please round the value of r to 3 decimal places. Okay, so this is the rule, 3 decimal places for the final answer of correlation coefficient. So when the value of r is negative 0.944, so the negative sign indicate that the relation between number of absence and final marks is the negative relation. So how to interpret? Okay, the more absence student has, the lower is his or her grade. Okay, so the more absence, the grade will be lower lah. Okay, all right. For the second example, I put this as exercise. Maybe you can try first before you proceed with this video to see the answer. Compute the value of the correlation coefficient of the data given below for the number of hours person exercise and the amount of milk a person consume per week. Okay, maybe you can pause this video and try to answer this question, and after you get the answer, you can compare with the solution that I give in this video. Alright, okay. Okay, the formula. Alright, the formula to find the correlation coefficient. So R is N multiplied by, sorry, I have a problem with my tablet pen. So R is equal to N multiplied by the sum of xy minus the sum of x multiplied by the sum of y, divide by square root of n, the sum of x square minus the sum of x all this square, multiply by square root of n, the sum of y square minus the sum of y all this square. Alright, so just like the previous example, we need the value of the sum of xy, the sum of x square, and the sum of y square. Okay, the sum of x square and also the sum of y square. So from the second column here, we can get the sum of x. Okay, the sum of x, you just have to total up all the values in in this column. So the sum of x is 36, and from this, the third column, we'll get the sum of y. So the sum of y is 370. Now we need to find the sum of xy. So for the new column, x multiplied by y, 3 multiplied by 48 is 144. So 0 multiplied by 8 is 0. So this 2 multiplied by 32 is 64. 5 multiplied by 64 is 320. 8 multiplied by 10 is 80. 5 multiplied by 32 is 160. 10 multiplied by 56 is 560. 2 multiplied by 72 is 144. And 1 multiplied by 48 is 48. Okay, you just have to total up this column to find the sum of xy, and the sum of xy is 1520. Alright, so next column, we find x square. So x square, 3 square is 9, 0 square is 0, 2 square is 4, 5 square is 25, x square is 64. 5 square is 25, 10 square is 100, 2 square is 4, and 1 square is 1. And total up this column, and we will get the sum of x square. And the sum of x square is 232. And the last column is for y square. So 48 square is 2304. Next is x square is 64. 32 square is 1024. 64 square is 4000. Sorry. See where 64. Now we have to calculate 64 square. So 64 square is 4096. Next is 10 square. 10 square is 100. Then 32 square is 1024. 56 square is 3136. 72 square is 5184. And 48 square is 2304. And total up to find the sum of y square, and the sum of y square is 19,236. And from all the values here, you just have to substitute in the formula to find the sample correlation coefficient. Now n, and the number of sample 1 2 3 4 5 6 7 8 and 9. So n is 9. The sum of xy is 1520 minus the sum of x is 36. The sum of y is 370. Divide by square root of n is 9. The sum of x square is 232 minus the sum of x is 36 square. Multiply by square root of n is 9. The sum of y square is 19236 minus the sum of y 370 square. Right, so use your calculator to find the value of r, and for this question the value of r is 0.067. Okay, 0.067. So this is a quite small value and near to 0. So we can conclude that the value of r indicates a very weak positive relationship between these two variables. Okay, very weak. which is less than 0. Less than 0.2. Okay, the value of r is less than 0.2. All right, we proceed to the next part to test the significance of the correlation coefficient. So to make a decision, use the hypothesis testing procedure. We have 5 steps here. For the first step, you have to state the hypothesis. So the second step, find the critical value. Next, we compute the test value. Then we make the decision. And final step, we can summarize the result. Right? So this is the step for the hypothesis testing to test the significance of the correlation coefficient. In hypothesis testing, one of these hypotheses is true. So H null rho is equal to 0, where rho is the correlation population correlation coefficient, and this null hypothesis means that there is no correlation between the x and y variables in the population, and the alternative hypothesis means that there is a significant correlation between the variables in the population. And when this null hypothesis is rejected at the specific level, it means that there is a significant difference between the value of r and 0. And when the null hypothesis is not rejected, it means that the value of r is not significantly different from 0 and is probably due to chance. Maybe we can try one example on hypothesis testing, and this is the formula for the t-test for the correlation coefficient. We use t distribution. T is equal to r multiplied by the square root of n minus 2 divided by 1 minus r square, with the degree of freedom equal to n minus 2. Okay, so the degree of freedom is n minus 2, where n is the number of sample. So we use the degree of freedom to find the value from the t distribution table. Okay, let's try one example. Okay, let's say we want to test the significance of the correlation coefficient in the second example. Now we use the significant level alpha is equal to 0.5. This is from the second example about the number of absence and the final grade. And from that example, okay, the value of r is negative 0.944. Okay, so this is the value of r. To proceed with hypothesis testing, first step we have to state the hypothesis. So the null hypothesis H naught is rho is equal to 0. The population correlation coefficient is equal to 0, and H1 is rho is not equal to 0. Okay, rho is not equal to 0. Then second step, we find the critical value. Okay, find the critical value. So to find the critical value, we will refer to the t distribution. Okay, t distribution table with the degree of freedom is n minus 2. So n minus 2. Now we have the number of sample is 1, 2, 3, 4, 5, 6, and 7. So the degree of freedom is 5. N minus 2. 7 minus 2 is 5. And alpha is equal to 0.05. So by using the t distribution table, okay, by using the t distribution table, the value of to find the critical value, okay, to find the critical value when alpha is 0.05 for two-tailed test, and n is degree of freedom is 5, so the critical value is 2.571. Okay, the critical value is 2.571. So um, you can see from the distribution, so this is 2.571 for two-tailed test. So this is for the negative part, so negative 2.571. So this is the critical region. So this is what we call the critical region, and we will reject H null. Okay, we will reject H null if the test statistic uh, that we'll calculate uh, is in the critical region. Okay, if the value is in the critical region, we will reject H null. Alright. Then next step, we have to compute the test value. Okay, for the third step, we have to compute the test value, where the test value by using the formula from the previous slide, t is equal to r square root of n minus 2 divide by 1 minus r square. Okay, so r, the value of r here from the previous example, so r is negative 0.944 multiplied by square root of n minus 2 is 7 minus 2 divide by 1 minus r square is negative 0.944 square. Okay, you just have to use your calculator to find the value of these test statistics. 0.944 square, so 1 minus r square, then multiply by negative 0.944. So the answer is negative 6.397. So this is the value of test statistics, negative 6.397. So after we get the value of test statistics, we can make the decision for the next step, and we can summarize the result. So how to make the decision? So now we see the test statistics value is negative 6 point negative 6.397. So negative 6.397 is in the critical region here, somewhere here. Okay, somewhere here, negative 6.397. Okay, so the value of test statistic in the critical region, so that we can reject H naught. Okay, we have to reject H naught. So we only reject H naught when the test statistic value in the critical region. And for this question, since the test statistics is in the critical region, that means we have to reject H naught. So the decision is reject H naught. Okay, reject H naught. So how to make the conclusion when you reject H naught? Okay, you reject H naught. So we have to accept H1. Okay, we have to accept H1. And how to make the decision when you reject H naught? That means at the significant level 0.05, there is a significant difference between the number of absence and the final marks. Right? So you can refer to the previous slide to make the conclusion. Alright, so when you reject H naught, that means at the significant level 0.05 for this question, there is a significant difference between number of absence and the final marks. Okay, and the final marks. Alright, um, this is an exercise for you. Maybe you can try to compute the value of the correlation coefficient for the data given below for the number of hours a person exercise and the amount of milk a person consume per week. So this is from the previous example also. The value of R, if I'm not mistaken, is 0.067. Okay, 0.067. So you just have to use this value, and now n is equal to 9. So the degree of freedom will be 9 minus 2 is 7. And what else you need? Yeah, that's all. So you can refer to table with alpha is equal to 0.05 and for two-tailed test, and you just follow the step before you can get the conclusion, the answer, the decision, and also the conclusion. All right, so I think that's all for the first part of this lecture, that we focus on the correlation. All right, thank you.